Hey guys, this is video 9-6 and we are going to be talking about molar volume. So far in this unit we've talked about two ways that we can use moles. We've talked about using moles to count things, so for counting, right? Anytime we use moles for counting, we use the value of 1 mole equals 6 times 10 to the 23rd. And we've also talked about moles, or using moles for mass, to determine the mass of a certain amount of particular compound or element. And for that, we've said that 1 mole is equal to the mass on the periodic table in grams, right? So these are the two ways that we've used moles so far. Now we're going to add a third way, and we're going to use it for volume. Volume is the amount of space that an object takes up, or in this case, gas takes up. Okay, and the key idea that you need to understand is that the volume of a gas changes with pressure and temperature. In other words, if I increase the pressure, the volume of the gas is going to shrink. If I release pressure, the volume of the gas is going to expand. If I increase the temperature, gas will expand. If I cool a gas down, a gas will condense or take up less volume. So that's the problem that we deal with as scientists, is that if these two values change, the volume will change. And because of that, most scientists work with gases at STP. STP stands for standard temperature and pressure. Okay? And the actual values of STP are as follows. So standard temperature is 0 degrees Celsius or 273 Kelvin, okay, and standard pressure is 1 atmosphere. So that means that under like laboratory conditions, I guess, you would keep your gas that you're working with at these conditions, and then you can predict how much space it will take up. Okay, and it turns out the guy who actually came up with the concept of a mole, Avogadro, dealt with this. In fact, he created what's called Avogadro's law. Avogadro's law says that the molar volume, or the volume that any gas occupies at STP, meaning at 0 degrees Celsius and 1 atmosphere, is always equal to 22.4 liters. So basically 1 mole of a gas, and it can be any gas, okay? It could be oxygen, could be nitrogen, could be neon, any gas whatsoever. If you have a mole of it at STP, it occupies 22.4 liters. So if you had 1 mole of oxygen gas, or O2, what volume would it occupy? Well, it's 1 mole, and if we assume that it's at STP, it occupies 22.4 liters. If I have 2 moles, that means I have twice as much oxygen. If it's still at STP, then what volume would it occupy? Well, it would occupy twice the volume because I have twice the amount. So 22.4 times 2 is going to give us 44.8. 44.8 liters. Okay, now I did this in my head, I did this simply, but remember, in chemistry class we need to write everything out so that we don't make any mistakes. And when it comes to converting numbers, we need to use dimensional analysis, which means given dot line. So let's do a little bit of practice and let's see how this works. Okay, so we've got 2 practice problems here. The first one says, what is the volume of 3 moles of carbon monoxide at STP? So the first thing we do is, reading through this, we look for the given number. We want the given number and its units. So that would be right here, 3 moles. So 3.0 moles. Okay? Now, I suggest that you get in the habit right now of also writing down the substance, which in this case is carbon monoxide. Okay? It's going to be really, really important in the future. In fact, it's going to be totally mandatory to write the substance in the future, but I know that we're getting in the habit of this again. So my suggestion is right now, get used to it. You know you have to put units down. We don't have any naked numbers in this class, but so you have to do the units, but get in the habit of writing substances as well. Okay, so the next thing I do is I do my dot and my line. Okay, and so I've written the given, dot, line. Next thing is I need to set up the units. So I need my units. I deal with units before I deal with numbers. So the first thing that I know has to happen is I have to get rid of my old units. So if moles are up here, I need to put moles on the bottom to get rid of them, right? Now, next question is, what units do I want? Well, they say what is the volume. Well, in the case of molar volume, that means our units are going to be liters. Just like in the case of molar mass, our units were grams. So liters gets plugged in right there. Okay. The rule still holds that as of right now, until I tell you about the exception, we always put a 1 next to mole. Okay. So the question is, what number do we put here next to liters? Well, it's Avogadro's other number, 22.4. This is the molar volume number. Remember, 1 mole of a gas at STP equals 22.4 liters. Okay, so that's why we can plug in 22.4. And it turns out anytime you're dealing with the volume of a gas, you plug in 22.4 when you're trying to figure out the volume. Okay, so moles cancel out. We're left with 3 times 22.4, which is going to give us 67.2, and then our units are liters. Don't forget the substance, so in this case it's carbon monoxide. Alright, what I would suggest right now is the next problem, pause the video, try the next problem on your own. If you get stuck, start the video and see where you went wrong, but try and get all the way through the problem, come up with an answer, and then see if you got this right. So pause the video and try it now. Alright, hopefully you tried it. So it says, how many moles of dinitrogen monoxide do you have if it has a volume of 44.8 liters? So where's the given? Well, the given's over here. Okay, so it's 44.8 liters. Don't forget the substance, so in this case N2O. Then dot line. Okay, we know we want to get rid of our old units, so I'm going to put liters down here. They say how many moles, so that's going to be our new units. Okay, 1 goes next to mole. So what number goes here? Avogadro's other number, the 22.4 liters. And if you're worried about remembering this number is actually on the back of our class periodic table. So if you ever forget, is it 22.4? Is it 22 point? What is it, right? You can flip over your periodic table and it's listed there for you. Okay, so that said, we can cancel out liters here, right? And then we're left with 44.8 divided by 22.4, which turns out to be 2 units or moles. Don't forget the substance, N2O. Alright, so that's that. We'd have a third thing that we can do with moles now. Make sure that you complete your whisk, and we'll see you tomorrow.